All right, Math Stars, our last lesson of Algebra 2 for the year. My accessory I was using to create videos on my iPad just stopped working, so I'm kind of going old school. I'm just going to be writing under my camera. So what we're going to do today is we're going to simplify radicals. So the same rules are going to apply if you were to simplify like 4th roots, 5th roots, 6th roots. But just to simplify things today, we're only going to simplify square roots and cube roots. Okay, so let's just make sure we're really familiar with the perfect squares. So I'm just going to list out the first few perfect squares here. Okay, I don't think I missed any. 2, 3, 4. That looks good. Okay, and then to simplify cube roots, we have to be really familiar with the perfect cubes. So let's write those out. 1 cubed, 2 cubed, 3 cubed, and so on. Okay, so let's simplify square roots first. So when we're square rooting a power of x, what we're going to do is we're going to divide the power by 2. So if we have x to a power and we're square rooting that, we divide the power by 2. Okay, let's do a bunch of examples of simplifying square roots. So this first one, and actually I'm going to move this paper so I don't get a bunch of marks on it. Okay. The first example, we're going to look at our list of perfect squares. So 162 is not on our list of perfect squares up here, but I can factor out one of these perfect squares. So 81 is a factor of 162. So earlier in the year, we simplified radicals like this. 81 times 2 is 162. So simplifying, the square root of 81 is 9, and that simplifies to 9 root 2. So when we simplify a radical, we're just trying to get the number under the radical as small as possible by factoring out any perfect squares. Okay, the next one. We had a hint that we wrote down above this. It says when square rooting a power of x, divide the power by 2. So when you square root that power of x, divide the power by 2, we get x squared. Okay, the next one, 7 is not divisible by 2, but what we can do is we can rewrite this as x to the 6th times x to the 1st, because x to the 6th is divisible, or 6 is divisible by 2. So when we rewrite it that way, we can square root x to the 6th. So that's going to be x cubed because we're dividing the power by 2. And then we're just going to leave this other x under the square root. So it's kind of like 7 divided by 2 is 3 with a remainder of 1. When you take 7 divided by 2, you get 3, and then your remainder is 1. So there's 1 x left over here. Okay, next example. Can we square root 4? Yeah, dog, it's perfect square. Square root of 4 is 2. We can square root x to the 12th by dividing that power by 2, so we get x to the 6th. Okay, the next one, is 12 a perfect square? It is not, so we're going to go back to our list of perfect squares and factor one of these out of 12. Well, which one can be factored out of 12? 4 can. I'm going to use 4, and then I'd have a factor of 3 left over. X to the 5th is not a perfect square, but x to the 4th is. So I'm taking out that even power, and then I have 1 x left over. Let's square root that first expression, 2x squared, because the square root of x to the fourth is x squared. Divide the power by 2, and the root 3x stays. Okay. There's one special case. When you're square rooting something with an even power, a variable with an even power, and the answer is an odd power, you must use absolute value. So whenever you have an even index, like the kind of root it is, the number of the root, that's called the index. So like a fourth root, a sixth root, a square root, if there's an even index and an even power and you get an odd answer, you have to use the absolute value to get an odd power answer. Did we encounter any of those up there? Well, we have an even exponent here, so no, even exponent, but this guy, we started here with an even index because there's an index of 2. We have an even power. And then look in our answer, we have an odd exponent here. So we need to put an absolute value on the x cubed. On your performance task this week, you're gonna have, just to simplify, 2 radicals, and you're gonna have to make a video explaining how to do it. Watch out, one of your answers needs to have an absolute value on it. Okay, this guy. So the index here is even because a square root has an index of 2. When we square root x to the 10th, we divide the power by 2. Oh, even, but my answer is an odd power. Need absolute value. X to the 19th. Well, I can't square root that because that's not even, but I can rewrite this as x to the 18th and then an x to the first left over. What is the square root of x to the 18th? X to the 9th. And then that square root x is left over. This guy needs an absolute value because I had an even index here of 2 and an even index or an even exponent of 18. And I got an odd power here. This is really tough, but hey, you guys can handle it. You're math stars, you're math warriors. Step up and do it, you got it. Okay, so we have an even power, an even index, because again, the square root has an index of 2. So let's take 22 divided by 2, so we're square rooting that, and we're gonna get x to the 11th. Did we get an odd power in our answer? Yes. So there are videos online that explain why you need this absolute value. Just to simplify this video, I'm not going to go into why, but feel free to join me in office hours if you want to hear me talk about why we have to have the absolute value there. Okay, we're going to finish with cube rooting, and this is actually easier. That's because there's no special rule that where you the absolute value thing. So let me move this here, and I'm going to put those perfect cubes so they're really visible so we can refer to those as we work. When we cube root a power of x, we're going to divide the power by 3, or divide the exponent by 3. Okay, first example, the cube root of 16. 16 is a perfect square, but is it a perfect cube? It is not. But 8 can be factored out of 16. 8 is the biggest perfect cube that can factor out of 16. By the way, you can cube root a negative. You can't square root a negative unless you're using imaginary numbers, but if I had a negative coefficient under one of these radicals, you could proceed cube rooting a negative. The cube root of a negative is negative. Okay, let's cube root that 8. So we're going to get 2. Then this 2 must stay under the radical. Okay, next one. Is 9 divisible by 3? It sure is. So we're just dividing 9 by 3, and our answer is x cubed. Okay, next one. We're cube rooting x to the 13th. This 13 is not divisible by 2. I'm sorry, this 13 is not divisible by 3. We're now cube rooting, so we're dividing the powers by 3. So I want you to think, how would I split this radical up into a perfect cube and then any leftover x's? Like the largest perfect cube and then any leftover x's. Try to split it up there. We're going to go x to the 12th because that's the biggest number divisible by 3 that's less than 13. And then we're going to have x to the first left over. 12 divided by 3 is 4, so x to the 4th, and then the cube root of x. Okay, next one. Is 27 a perfect cube? I see it here. It is. So we can cube root 27 and get 3. X to the 15th is also a perfect cube since that power is divisible by 3. So we get x to the 5th. That's all we're doing on that one. Okay, next one is the cube root of 4x to the 6th. 4 is not on our list of perfect cubes. I can divide a 1 out, but that's not going to make it any smaller. So I can't really do anything to reduce that 4 under that radical. But I can cube root x to 6 since that's divisible by 3. So I'm going to take 6, divide by 3, and get x squared. And that 4 just remains under the radical. Okay, next one. So this is not a perfect cube. I know I didn't make the list that high, but I just happen to know that that's not a perfect cube. But I can factor out the 512 because I can tell that 1024 is double of 512. So let's factor out the 512. Let's put that in the first one because that's where the perfect cube is going to go. So 512 times 2 is 1024. Can I cube root x to the 9th? Yes. I'm going to put that here. The reason I can cube root it is because 9 is divisible by 3. So the cube root of 512 is 8. And then dividing the power by 3, we get x cubed. And then this little old 2 stays back here in the radical. Almost done. Last lesson of the year. Okay, this guy. It's 24 perfect cube. It is not. It's not on my list of perfect cubes. 8 is, so I'm going to factor out an 8 because 8 is a factor of 24. 8 times 3. 11 is not divisible by 3, so I'm looking for the biggest power of x that's less than 11 and divisible by 3. So count down from 11. Is 10 divisible by 3? No. Is 9 divisible by 3? Yes. How many x's are left over? X squared. So everything in this first radical is a perfect cube. Everything in the last one is not. Oops. So I'm cube rooting this first expression, and that's going to give me 2. Divide the power by 3. This stays. So what are we really doing when we're simplifying that first radical? We're cube rooting the coefficient and dividing the exponent by 3. Cube root the coefficient, divide the exponent by 3. Hey, that would be something good to put in your summary or jot it down in your notes. When you simplify the cube root, you cube root the coefficient and divide the exponent by 3. What do we do when we square root, like we did on the front page of the notes? Let's go back to one of those real quick. What do we do when we square root? We square root the coefficient and divide the exponent by 2. Square root the coefficient, divide the exponent by 2. Back to our last one. Last example of the year. Kind of makes me weepy. Hey, I'm not going to do this right off the bat for you. You guys try it. So I'm gonna just be quiet, take a sip of water. You guys try it. Okay, so in the first radical, things that can be divided by powers of the variables that can be divided by 3. I'm going to write y to the 9th, x to the 9th, y to the 21st. When I take away x to the 9th from the x to the 11th, I'm left with x squared. Now when we cube root those variables with exponents, we're dividing the exponents by 3. This remains under the radical. All right, last lesson of the year. Keep it honest when you do your performance task, please. See me in office hours if you need any help. All makeup work is due by the end of the day on Thursday, May 28th. So keep it honest, keep working hard. Proud of you, Math Stars. Take care.